Hi everyone, this is Mrs. Torigno, and this is your first official Algebra 1B lesson. We're going to start talking about functions today, and we're going to talk about functions for the rest of this week, a little bit of next week, and then you've got a quiz coming up next week over these functions. Okay, so let's talk about what a function is. I know this definition looks really scary, but a function is a relationship, and that is the biggest thing I want you to take note of here. Is that when I'm talking about a function, it's a relationship between two sets of things. So it's a way that two groups of items are linked together, okay? Such that each value of the first set corresponds to exactly one, and that's another big key, exactly one value of the second set. So you've got one group of items that are being linked up to another group of items. Each item in that first group is only allowed to link to one thing in the second group. That's what this exactly one statement means. Now, it's okay if two items from that first group link to the same item in that second group. They can double up that way. But you can't have one item that's mapping to more than one thing. And you'll see what I mean when we talk about a couple of examples. So, for example, if I set up a relationship where I said each student is mapped to his or her third-hour teacher. So if I put all of the students in this school and all of the teachers in this school in a room and said, everybody go run and find your third-hour teacher fast, everyone would only be looking for one person, okay? Now, it's possible that more than one student, enjoying my artwork, here are the students, more than one student might be looking for the same teacher. This is my attempt to make them look bigger. So this person might have this third-hour teacher. This person might have third-hour teacher. That's okay, okay? As long as each person over here only is being linked up with one other person. So when I throw all those people in the gym and I say, find your third-hour teacher, every student is only looking for one teacher. If I reverse that, if I put everybody in the gym and I said, okay, teachers, find all of your third-hour students, the arrows would be going back the other way, and that's when it's not okay. Okay, that's not a function. So a function is when there's only one link from that first group to the second. Here's another non-example. If every U.S. resident is mapped to his or her pet, so if I put all of the people in the United States in a room and I put all of the pets in a room and I said, go find your pet, it's possible that one person from that first group, the U.S. residents, might be looking for both, oh boy, a dog and a cat. That's awful. So this person might be looking for this dog and for this cat, and that doubling up right here, that's what's not okay. Okay, that makes this not a function. Okay, so it's going to be important that you can identify functions and non-functions. Okay, so an example, a more mathematical example for you. Here's a table that shows what percent of high schools in the United States had computers in these years, going way back to 1981. And I want to know, is P a function of Y? Well, when it's worded like that, is P a function of Y? That makes this, whatever it's of, the independent group. So that's where you want to look for your doubling up. You want to make sure that every year, because that's my independent group, is only mapped to one percentage. So take a look here. 1981 only has one percentage. 1982 only has one percentage. And I could do that same thing all the way down the line. Really what I would be looking for here is to see if any single year shows up more than once, if it's mapped to more than one thing. And in this case, it's not. Okay, so yes, okay, and you can choose to word that however you want, but no Y values are paired with more than one value of P. So there are no values up here in the Y column that have more than one partner. Now, you will see that like here, for example, 99.1 shows up twice. That is okay, as long as it's got two different numbers that are going to it. Okay, but what wouldn't be okay is if 1986 was up here twice. Okay, so it's the it's the first value that you're worried about with functions. Okay, the parts of a function. So we've been talking about kind of that first group of things and the second group of things. Okay, the first group of things are being mapped to the second group. That first group is called the domain. That's the possible values for the independent variable. Okay, that's the first group that we were talking about a second ago. Okay, that's going to erase in a second. But so the independent variable is that first group of things. The range is the possible values of the dependent variable. And this is all very mathematical and technical, but basically this is the set of things that that first group is being mapped to. So if you look at this, and this is another way to write a function, I'm showing that 2 is matched up with 9, and 8 is matched up with 4, and 5 is matched up with 12. This is a function. This set of numbers here on the left would be the domain, and this set of numbers here on the right would be the range. Okay? Because this is the things that are being mapped to these things. So back in that very first example where I said every student was mapped to his or her third-hour teachers, the domain would be the set of all students, and the range, what they're being mapped to, is the set of all third-hour teachers. Okay? So that's domain and range for you. Let's look back at our computer example. This time we're being asked to give the domain and the range. So remember, domain is the first group that's being mapped to the range, or the second group. Domain, I would just say it's all of these. Now, a second ago, when I did that example with the students and the teacher, I just wrote domain is all of the students. That's because I can't list every single student that's at this school. I mean, I suppose I could, but I wouldn't need to. But in a case like this where they give you actual numerical data, it's not enough to just say the domain is the year. Okay? You would have to actually list the years that are listed in the table. And then the range, of course, would be that next group. The range would be all these percentages. One thing I will point out, I shortened this table from the last example. If you do have a number, I don't know if you remember before, we had 2 of these 99.1s. If you have a number that shows up twice in the range, you don't have to list it twice. You can just list it once. Okay, so a problem like this, domain, I would list these numbers. Range, I would list these numbers. Before we move further, we need to talk about what different groups of numbers are called, because you're going to get to a point where you can't possibly list every number, but you need to somehow identify the group of numbers that your domain and range falls in. So I'm going to start from the inside out here, and some of these you've probably heard before, but the natural numbers, those are your counting numbers. So they start at 1, and it's just 1, 2, 3, 4, 5, 6, 7, 8, and so on. Okay, that's natural numbers. Okay? Whole numbers are almost exactly like natural numbers, except they include one other thing. Notice how this one started down here at 1. This one includes 0. So 0 is considered a whole number. You're still not including negatives, but you are including 0. When you jump out to integers, now negatives get to join the party. Okay, so these are like your counting numbers on the inside. These are, here you get to add the 0 in, and then for integers, that's where you get negatives. Now notice these are still happy whole numbers. Okay, just some of them are negative, some of them are positive. You haven't gotten into decimals or fractions yet. Then you get into rational numbers. That's where you get fractions and decimals, but we have to be careful here. It's decimals that either repeat or terminate, which means they end. Okay, so decimals are considered to be rational numbers as long as they either repeat, like this one does here, or they terminate, like this one does here. If it's a decimal that doesn't end and doesn't repeat, that is what's called an irrational number. That's over here, and that's not considered a type of rational number. If you were to type in square root of 2 on your calculator, you would see a crazy decimal that would keep going on and on and on. That's irrational because it does not end and it cannot be written as a fraction. And all of those numbers all put together are considered the real numbers. So when you start talking about the domain and range for problems and you need to think about what kind of numbers are reasonable to put in there, sort of I go through this process. Can I put in just regular plain Jane 1, 2, 3, 4 type numbers? Can I put in 0? Can I put in negatives? Can I put in fractions? Can I put in fractions even, or can I put in decimals even if they don't end or repeat? And if so, if I can put all of those groups of numbers in, then I say, okay, I can use real numbers. If I have to stop anywhere along that journey, that's where I would say, all right, it's this group of numbers in particular. So let's talk about this. Use the equation y equals x squared plus 2 for the following. Is it a function? Now, we haven't talked about equations with functions yet, but here's what I want you to think. If you put a number in here for x, and then you solve this problem, how many answers do you get out for y? Okay, so if you put a number in for x, how many numbers do you get out for y? So let's take the number 5. Well, if I put 5 here, I would do 5 squared is 25, 25 plus 2 is 27, so I put one number in, I get one number out. Can you think of any way that I could put a number into that where I would get two different answers back out? I can't, okay? We would say yes, this is a function because every time you put an x number in, there's only one answer for y. I will tell you right now that the only equations that are not functions would be equations where you can get multiple answers for them. And that would be the square root and sometimes absolute value. I don't know how much work you've done with absolute value, but these two symbols in your problem kind of mess up the function thing for you. Okay. I might actually, I might skip around a little bit. Okay, ignore that big black smudge up there. Okay, we'll come back to that in just a minute because I will answer that question, but I want to go back to what we just talked about here in Part A where we said yes, it is a function, and I want to look at this. Now, is this a function? Well, if I take the square root, whoops, I need to change my pen here. I take the square root of 25. What is the square root of 25? Did you get 5? I hope so. And it's 5 because if you take 5 and square it, you get 25 back. Okay, that's what square root means. But there's another way that you could square a number and get 25. All right, so start thinking about that. Hopefully you came out with -5, okay, because -5 squared is also 25. So when you take the square root of 25, when I put 25 in place of x, I get 5 as an answer and I get -5. And so because I get two different answers, this is okay. I want to go back up to this top one and talk about the domain and range. Remember, domain, the question that you were being asked when you were asked for the domain, is what numbers can I put in for the independent variable? What kinds of numbers is x allowed to be? So let's go back through that list. Can it be just 1, 2, 3 natural numbers? Yes, it can be. Okay. Can it be 0? Could I do 0 squared plus 2? Sure, 0 squared plus 2 is just 2, because 0 squared is 0, plus 2 is 2. Okay, can I do negatives? Could I do -5, let's say? Maybe let's do it this way. I'll actually write out. Can I make it negative? Are you allowed to square negative numbers? Yes, you sure are. You're not allowed to square root them, but you can square them. There's a difference between squaring and square rooting, so that works. Could I make it a fraction? Sure. You could square 3/4. 3/4 squared would be 9/16. So that would work. So if I go through this whole list and everything works, I'm going to say that the domain is all real numbers. This is going to look a lot prettier in just a second. Okay, the domain is all real numbers. Now let's talk about range. The range is what kind of answers do you get out for y when you do put numbers in for x. And this is where it gets a little bit interesting. If we do, let's do 2. If I do 2 squared plus 2, well, 2 squared is 4 plus 2 is 6. Okay? When I do 0 squared, this is where I'm just kind of picking numbers to plug in, 0 squared plus 2 is 2. So now we need to pick something smaller than 0, because I went from 2 down to 0. Let's go with maybe, I don't know, -1. I'm running out of room here. So I'm going to do -1. By the way, in your calculator, it's very important that when you square a negative number, you put it in parentheses. If I take -1 and square it and add 2 to it, well, -1 squared is just 1, and 1 plus 2 is 3. So look at that. As I was going down, as my x values were decreasing, I went from 2 to 0 to -1. Look what happened. I went 6, 2, and then back up to 3. Why do you suppose that is? Well, it's because of what happens when you square a negative number. Okay, when you square a negative number, it turns back to positive. If I square -4, -4 squared, as long as I type it in my calculator correctly, comes out to be +16. So it's almost like these numbers are going to get smaller and smaller and smaller until I get down to 0. So this is like the lowest I'm ever going to get. And then if I go back up to -1, those numbers are going to start creeping up again. Watch what happens if I do -2. Whoops. So -2 squared plus 2. Well, -2 squared is still 4. Okay, as long as you type it in your calculator correctly. And 4 plus 2 is equal to 6. So with -2 and with +2, I got the exact same answer out of that. So think about what kinds of numbers your answers can be. They can be anything except numbers that drop below the 2. Okay, because we weren't able to get any numbers that would be below 2. In fact, I dare you to try it. Let me know if you come up with a number that you could put in there for x and get a number smaller than 2. But until you figure that out, the domain and range, domain is all real numbers because we said we could put anything we want in for x. And the range is everything. You can get every kind of answer you want as long as it's not lower than 2. Okay, so that's your domain and range. And then just real quick, let's look down here at example 4, identify the domain and range. I can't because I just said it's not a function. So this one doesn't have a domain and range because it's not a function. Okay? Okay, so let's take a look at this one. First of all, is it a function? If I put a number in here for x, is there any way I could get 2 different answers out? No. No, I can only get one answer out. Because again, the thing you want to watch out for 2 answers is the square root. That's when you're going to get your 2 answers. Okay. Function, every time you put an x number in, there's only one answer that you're going to get out over here. Identify the domain and range. Okay, this is another tricky one. The thing you have to look out for when you're talking about domain is you're asking yourself, what numbers can x be? That's a tough question to ask, what can x be? Because there's a lot of things x could be. So sometimes it's easier to ask yourself this question instead. What is x not allowed to be? And this is a fraction, so we need to think about what types of things are not allowed in fractions. If we were in class right now, I would let you speculate for a little bit about what's not allowed in a fraction. But I'm going to tell you right now that in a fraction, you can't have a 0 in the denominator, in the bottom. Hopefully someone has told you that at some point in your life. Okay? No 0 in the bottom. So that means what I need to make sure of when I plug these numbers in for x, I can plug in anything I want as long as it doesn't make it so that there's a 0 on the bottom. Well, on the bottom I have x squared minus 36. How would I make that equal to a 0? How would I make x squared minus 36 equal to a 0? Whoops. That would only happen if this x squared were equal to 36. Because then I would have 36 minus 36 would be 0. So how could we get x squared to equal 36? Well, if x squared equals 36, then that means x could equal 6. Or think about what we just learned a minute ago. What else could square and make 36? X could equal negative 6. So I need to make sure I don't use either one of these numbers, because if I put one of those numbers in, it's going to take this x squared minus 36 and make it equal to 0, and that 0 is not okay. So I want to somehow say x can be anything I want except these two numbers. Okay? And so here's all real numbers. It can be anything we want except 6 and negative 6. For range, you think about what kind of answers can you get out. Well, could you get a positive answer? Sure, if the top is positive right now. Okay? So if we worked it out so that this came out to be positive, you'd have positive divided by positive, you could get a positive answer. What about negative? Well, that top is still positive, but if we worked it out to where this x squared was smaller than 36, and then we subtracted, this would come out negative. And so then you'd have positive divided by negative. Negative works. Can you get a fraction out? Sure, it's already written as a fraction. Okay? So your only possible answers here, or I'm sorry, I missed one. The one thing we didn't check was 0. Okay? And I want you to think about, we've got a 25 on top there. Okay? And that 25 is not going anywhere. That has to stay part of the problem. So we've got a 25 on top. We can kind of change the number that's on the bottom depending on what we put in for x. We can structure that. How would I do that? 25 divided by some mystery number that's equal to 0. 25 divided by what makes 0? And it's not 0 because we said we're not allowed to put a 0 down here. Okay? The answer is nothing. You can't get a 0 answer. You can get positive answers, you can get negative answers, you can get fraction answers, but you cannot get 0 answers. And so for this, for the range, all real numbers except 0. Okay. All right, the stuff that we've covered so far is what goes along with Lesson Master 1-2, and that's an assignment you'll be working on. Either if you have it with you now and you want to work on it now, great. Otherwise, you'll be working on it in class on Monday. Thanks for your time.